Today we're going to be simplifying rational expressions. We will use factoring to simplify rational expressions. So a rational expression is in simplified form, provided its numerator and denominator have no common factors other than 1. To simplify rational expressions, we must divide out common factors. So these problems you should have seen before in previous math classes, but we're going to review some of those before we get into ones where we need to do some more factoring. So we have a 3 here. The only factor of 3 is 3 and 1, so we're just going to leave it as 3. M to the 5th means the same thing as M times M times M times M times M. 1, 2, 3, 4, 5 of them. So M to the 3rd would be M times M times M. So common factors. There's one on the top, one on the bottom. One on the top, one on the bottom. One on the top, one on the bottom. So that leaves us with 3 times M, which would be M squared in the numerator. And there's nothing left in the denominator, so it technically would be over 1. And we don't need to write anything. In the second one, we have x times x, because it's x squared, over x times x times x times x times x times x. So the 2 that are on the top will cancel with 2 of the ones on the bottom. Since that leaves nothing in the numerator, we need to have a 1 there to save its place. And then since there's 4 x's left on the bottom, it would be over x to the 4th. In the third one, they both have y to the 4th, so those would cancel out. Again, since nothing's left in the numerator, we leave a 1 there, and all that's left in the denominator is 2, so this simplifies just to 1/2. Since the last one has more numbers and letters, I'm going to separate it into different pieces. So we have 3 over 9, those are our coefficients. We've got h cubed. There's no h's on the bottom, so I'm just going to leave a 1 down there. We've got j cubed, and there's a j on the bottom. And we've got k to the 4th, and there's a k on the bottom. 3 over 9 would simplify to 1/3. H to the 3rd over 1 would just say h to the 3rd over 1. Since we had 3 j's on the top and 1 on the bottom, that would simplify to j squared over 1. And k to the 4th over k would simplify to k cubed over 1. So in the end, 3 is the only thing in the denominator, 3 times 1 times 1 times 1. And then in the numerator, we'd have h cubed j squared k cubed. So in general, with the exponents, you're subtracting them, and then if there's more on the top, the exponent will be on the top. If there's more on the bottom, the exponent's on the bottom. But what if we're given a polynomial? So these were all monomials, single terms where everything's being multiplied together. Here we have some polynomials. The first thing we have to do is factor so that we can divide out the common factors. And since we cannot divide by 0, we are going to state the domain. And basically it's going to be a domain restriction. And I'll show you what that means in a second. So first thing we've got to do is factor. So x squared minus 81, that follows our difference of squares pattern. So it's going to be x minus 9 and x plus 9. In our denominator, we have a common factor of 2. And when we factor that out, then we're left with x minus 9. Before we do anything else, once we've factored, we want to write the domain. Since this 2 does not have an x, we don't have to worry about it. X minus 9 here does have an x. X minus 9 equals 0, we're going to have a problem. So if we solve that, we get x equals 9. So we know for our domain, x such that x does not equal 9. X can't equal 9. We don't want that to happen because that will cause our denominator to be 0. Now that we've stated the domain, we can go back and cancel any common factors. So there's a factor of x minus 9 on the top and on the bottom, so those can cancel out. That leaves us with x plus 9 over 2. So number 2, our factors of x squared plus 5x plus 6 would be x plus 2 times x plus 3. In our denominator, we can factor out a common factor of x squared and be left with x plus 3. So for our domain, if x squared equals 0, we have a problem. That would be if x equals 0. And x plus 3 equals 0. So if we solve that, we'd get x equals negative 3. So our domain would be x such that x does not equal 0 or negative 3. Now we can cancel our common factors. We'd have x plus 2 over x squared. Now, a lot of people will see this x squared and this x and want to cancel. Do not do that. Don't do that. That's not allowed. So this x on the top, it's not a factor because it's being added to this 2. It would be different, much different, if it said 2x over x squared. Then we can simplify that. But because of this plus sign, you cannot cancel this x with anything other than an x plus 2. So this is it. So basically you can't cancel something that is attached with a plus or minus to something else. Same idea over here. If the 2 had been a 3, you can't simplify 9 over 3 because the 9 is attached to the x with this plus sign. That's all for today. I'll see you in class.